Yes, hello everyone. Welcome to this evening's presentation. Very excited myself to hear about this. And so just a little bit short before we go into that. So I am Frederick and I represent DevOps Skåne, who is hosting this particular talk today. And with me today is also Karen and Albert. So all of us, the three mosquitoes, I almost said, musketeers. All right, yes, and hello also to people online, of course. Hope you will find this very interesting. And today, yes, we have to talk about the full story of software bill of materials. I think it will be a very interesting topic. So I hand it over to Lars and Andreas.
Yeah, thank you. Thank you for coming. Thank you for the welcome. I'm Lars Bendix. I'm from Lund University.
I'm Andreas Göransson from QCM.
And we're both members of a network called SNESM, the Scandinavian Network of Excellence in Software Configuration Management. So we are passionate about software configuration management, not about cybersecurity. But as you will see during the presentation, software bill of materials can also be helpful for cybersecurity. So the agenda for today is that we will start with a little bit of motivation, both for bill of materials, software bill of materials, and also for DevOps people, why they should be interested. We'll dig a little bit into the history, because it's not a new thing. And then we will show you that there is a lot of different use cases, not just the standard use case that had become popular lately. Then present some considerations that are general for all the use cases, some things that you should think about and reflect upon if you want to use and or create software bill of materials. And then at the end, we will show you some lessons learned that from our experience. Could you? Sure. Okay. So probably you know that President Biden has sort of mandated that at least if you want to sell software to the US government, then you must provide software bill of materials. And the EU is also following up. So there are some external requirements for you to be able to produce software bill of materials. It should have been an internal requirement that you could actually use software bill of materials for a lot of good purposes internally in your development since the conception of software bill of materials in the 1980s. DevOps developers, they are the perfect producers of software bill of materials, and both developers and operations should be heavy consumers of software bill of materials. We should do software bill of materials for anything. We want to know what it is that we have, and if we want to do change control or cybersecurity, it's very useful to know what is inside this thing, black box, white box, or whatever it is. We want to tell you the full story to widen the perspective of the software bill of materials. And software bill of materials is nothing weird. Here we have two examples of software bill of materials. It's very simple. This is a software bill of material. This should be a name, 5.13.7, 15,481. That gives a name to a data record where all the information about this version of SBoM is stored. All the information that we want to know. And if there's a new update available, don't ask me why they go from 7 to 10, but they did that. Then one of the things that they have as a part of the software bill of material is the release notes. So if we want to know something about the release notes, then we just go and look up the software bill of material by this name. And so it's as simple as that, a software bill of material. Nothing weird, nothing rocket science. So let's see what some people say that it is today.
Yes. So as Lars mentioned before, the US President signed an executive order 14028 a couple of years ago, and this was to strengthen the US ability to respond quickly to cyber threats. And for example, of those threats, it's Heartbleed and SolarWind. And it was developed by the US Department of Commerce and NTIA. And what they come up with was a list of ingredients, and it's primarily used for finding cybersecurity threats.
Yep, so let's fast rewind back to the future. It's not 2020 anymore. So let's see how software bill of materials were in the 1980s. I can see that maybe some of you were not around in the 1980s. I was. Wayne Babbage, my hero, wrote a book in the mid-80s, and in that book he says many times the fastest approach to finding a bug is not analysis of the program itself, but analysis of the history of the program, how it was created. The history of the program, he called it a derivation. Today we would call it a software bill of material. So the precise derivation, according to Babbage, is that we should identify the tools that created the data that was input to the tool, the compiler, loaders, and everything else, options and arguments, the reason why something was created, the person that we can go and blame or that we can go and ask for additional information, and date and time and anything that would be useful for you. And he says that an ounce of derivation is worth a pound of analysis. So his idea for using these software bill of materials was that if it doesn't work today, but it worked yesterday, then if we can compare and make a diff of these two software bill of materials, we have a starting point for where we should go and investigate to hunt down the bug or the problem that we have. Back to more past future.
Yep, Back to the Future 2. Some of you may remember Clear Case with the mixed feelings, but as a part of the tool chain from IBM Rational, they had ClearMake, and ClearMake automatically created software bombs, but they called it configuration records. And configuration records are used to reuse software in a smart and secure way, so that you know when you build something and you wink in object files, you know that you'll get the correct output. And configuration records contain information about what went into the build, input files such as source code, but also build switches, things like that, and also the output. And configuration records can be used by machines and also audited by developers. So it's both man and machine readable and usable.
Yep. So as you've seen in the 2020s, the NTIA, the Americans, they think that software bill of materials is something that they invented, and that it's a list of ingredients, and we use this list of ingredients to scan for vulnerabilities. Going back to the past, we have seen that they can also be very useful for a lot of other things. If we want to optimize the builds, then the clear case configuration records, which is nothing but bill of materials, software bill of materials, can be used to optimize this and to reuse things that we have already created. Wayne Babbage shows us that if we want to debug, there are easier ways than reading through 2 million lines of code. We can just compare these software bill of materials. So Andreas and I, we thought that we would look deeper into what is this actually, what can it be used for. So we searched through literature, and we interviewed around 15 people. Yep. Some people have been worked quite a lot with software bill of materials. One actually said that, well, during the 90s, they didn't deliver products to their customer. They delivered a bill of material and the source code. And then the customer created from the bill of material the executable himself. So software bill of materials is nothing new. We came to the conclusion that we had hundreds of different examples of use cases, and it became chaotic. And we said, we need a little bit of order. After all, we are configuration managers, so we live on order. So we tried to organize this, and we gradually figured out that we have sort of 3 overarching types of bill of materials. So we have the traditional bill of material, which is like also if you have a hardware bill of material. So Volvo has a bill of material for your car. They know exactly what is in your car and how it was built. It's hardware parts, it's a hardware bill of material, but then Babbage says that we also need to know how this thing was constructed. So we need to know something about the process, the tools that were used. And I doubt that Volvo has that for the cars, to know that you were the person that was at the assembly line when my car was assembled. But we need to include some things about the processes, and that is sort of a bill of process. And then when we looked into it, then there were more things than the processes. There were also general information. So we grouped then all the examples into categories. For the bill of material, it was sort of search for an object by a unique ID. For the bill of process, it could be used for a lot of different things: reuse, debugging, rebuild, build audits. And for information, I think that we gave up when we came to 5 overarching categories and said that, well, then maybe we should have various information. But in reality, there's no limit to what you would consider to be useful. So if we dig a little bit deeper into the 3 different overarching categories, then the bill of material thing, basically that has one use case category, that is the search for an object by a unique ID. So if I'm worried about log4j, then I get the unique ID for log4j, and then I look into the list of ingredients of all the products that I have and scan it and see, is there log4j? We interviewed some people who were doing software composition analysis, so they had to scrutinize the delivery, the potential delivery that they had gotten, to see whether features 12, 15, and 19 were actually included in that binary. So they were doing a scan, searching not for log4j or other malicious software, but whether the development team had actually included these new features into the binary that they had sent for quality assurance or whatever. We can get binary patches. Are they already in there? We need to search for them in the system, and operations should be very interested in what is it actually that is running on our system. One example that I use for my students is that in this company we have a generic logon module that is used in a lot of our products. Suddenly we discover that in version 2.1 of the source code there is a serious bug. Now, what are the products and the versions of the products where we use version 2.1 of the logon module? Not 2.0 because that doesn't have the problem, and not 3.0 because it doesn't have the problem. And then we discovered that we also have some additional problems, because in this company we have the habits that when I need to have the logon module in version 2.1, I compile it and I include it in my binary, my product. Guess what he's doing? He's doing the same. So now we cannot just scan this for a unique ID for the binary, because these 2 binaries, they are identical. They were compiled in the same way from the same source, but they have 2 different unique IDs. So now we need to have the possibility to scan also for a unique ID for the source code and have that connected to our software bill of material. So the plot thickens. Bill of process. Reproducibility, or to be able to produce something, is at the core of software configuration management. So for reproducibility, we need to have the source code. That's the obvious step. But we need to have more. So if you do escrow development, if you don't trust that your development company will be around for the next 40 years, then they have to deposit the source code. And then you think that everything is fine. But the day that they go bankrupt and you get the source code, what will you do with it? You cannot create the binary, the executable that you're using. You cannot go in and continue to work with that. At least you need to do a lot of work before you get up and running again. So we need the tools, how the tools are used, what are the options that we are using on the tools. If we have long-term maintenance contracts, so we have some trains in Denmark that are like 35 years old, and they probably still run the hardware that they were running 35 years ago. So, I mean, they will not run modern software. They will not run something. So if you fix a bug in that and compile it again with a new compiler, then you'll have problems. So you will need to be able to go back 13 years and be able to create exactly what you had then. And the degree to what you consider identical might differ. So if you are ABB doing control software for a nuclear power plant or for petrochemical installations, you have a very clean definition of what is identical down to the last detail. But if you're Spotify, you never look back. You don't care about some of these details. So it all depends on what is your context.
Yes, and we also saw that we need some information around the stuff in our software BoM. And that can be for communication or audits or certification or whatnot. So in this example, we go into the test-related matters that we've identified. For example, if a system or a program can affect human safety, then it can be vital to save the information about how you tested your software or your thing that you deliver. What hardware did you run the tests on? What test results did you get? There can be situations where you, as a company, need to provide proof that you've actually run these tests on a certain hardware. For example, if you have a car in an accident or something blows up in a nuclear power plant, then the authorities will come and audit you. Okay, why did this happen? That could be good to prove that you were right. It was someone else's wrong that did wrong. Also, test information can be used as a quality stamp that our software or our system passes a certain level of tests, and then we are certified for a certain legal requirements, for example. So in total, we try to be really pedagogic here. So software BoM is bill of materials, bill of process, and bill of information.
Yeah, and then when we sort of tried to publicize this on LinkedIn, we got a comment, a scenario that I don't know how much we had thought about that. Maybe not quite a lot, because it was a specific attack example from Julio Vian, and the description is a little bit longer than this in italic. But basically it says that an internal agent prefaces the source code or a tool that is used for producing the build with something malicious. So now we are not talking about outside people anymore. Now we're talking about you, that when you check out the code from the Git repository, you sort of put it aside and then you take your malicious code and say that, oh, this is what we should build. Or someone hacks our system and install a different fancy compiler that compiles backdoors into our code. Now, how do we discover that? Well, it means that we must have unique IDs not just for the binaries that we have, but also for the source code and the tools. So when you try to put away the version 2.7 of the source code that you checked out from Git, then and substitute that by something else, hopefully it'll get a different unique ID. Otherwise, we have a problem internally with how we assign unique IDs. That might be an issue, but then we are not we are configuration managers, not cybersecurity people, so we will outsource that to the cybersecurity people. And for our tools and for everything that gets into contact with building something. Can we trust our internal or external unique IDs? If we can sort of trust this, or even if we cannot trust, then I can give you the bill of material, and I can give you the bill of material. And then in your environments, from the bill of material, you can reproduce exactly the binary. If your system, if your compiler is hacked as well, you'll get something different using the same bill of material than what he gets. So we can have this build paranoia and have several people build this and then compare the binaries and see, are they identical? And then hopefully we can discover that something was compromised. There's a project, open source project, that is called Reproduce the Bill, and they sort of focus on some of these things.
Yes, so as Lars mentioned before, during our work with our white paper, we found things that were common to all the categories and use cases. And first of all, you need to decide, if you want to start to work with this, you need to decide what detail do I need to have in my software BoM? What data is needed? Do I need to format it in a certain way? Do I need to filter it before I show the information to customers, things like that? And after that, you need to make sure that the software BoMs, no matter where in the process they are, they should be available and usable. It can be in the form of a document, a make file, or a XML file, or whatever that can be read by a machine and processed by a machine, or converted to something readable for humans. If the SBoM is stored in a database, you should be able to query it to get the information that you need. And once that is in place, then you can start to prototype and start to automate. I mean, we're DevOps, so we want to automate stuff, right? Both creation and using. And one thing to keep in mind is that the data in the software BoM can be of a static nature or a dynamic nature. And what we mean by that is that we have version 1.0 of a software, and it's considered secure. A little bit further down the line, someone discover a problem with one of the components in our software. Then it's not secure anymore. Then we need to make a new drop of our software with the new software BoM. So that is what we mean with dynamic data. Even if it's considered, the program is considered secure at one point in time, later on it can be deemed unsecure due to outer circumstances.
Yeah, so we began with telling you how software bill of materials have become popular today by President Biden's presidential order. And the Americans and the NTIA has done a lot of work to make it a popular buzzword, to make sure that a lot of people came today. Maybe from some parts of our presentation, it seems like we think that they have done a lousy job. We don't. We think that they have been given a very, very narrow mandate, cybersecurity. And they have looked at software bill of materials from that perspective. And they have done a hell of a good job for representation formats, to try to find a format such that we can exchange these bill of materials. So every company doesn't invent its own format for the bill of materials and no one can talk to each other. But unfortunately, on their committee, there was no configuration management people. Or maybe there were, and they said, well, if we want to open up this can of worms, then it becomes unmanageable. We need to get a result. So they focused on the cybersecurity aspect, and they focused on the representation format, and they have done quite a good work. But we need to get on. We need to broaden it. So we also need, when if you want to use or produce software bill of materials, you need to address the fact of how do we keep the software bill of materials up to date. So when I download the new version of Firefox, I should download also the bill of material for that version of Firefox. So now I will have two software bill of materials. The Firefox that is actually running on my computer and the Firefox that I have been downloaded. And when I install that new one, then it should remove the old bill of material and maintain the new bill of material. Stuff like that, how you would address that. Windows, when you get a patch, you need to patch also the software bill of material. Otherwise, the software bill of material will become out of sync with what you actually have on your running on your system. One of the things that we also came across during the literature and mostly during our interviews was that we need to have, it's not so easy that we can just take the process for how we built this and say, well, that's how it is. Because we have some configurations, some parameterizations when we build the stuff. Will this be built for low memory with optimization? When we install something, maybe it sort of configures and says that this should run on a Mac or this should run on a Windows machine, and also at runtime. If you allow me as a user to say, no, I don't want that thing, I want this thing. If the Volvo crashes and we have to go to court, we need to know exactly what was the configuration, exactly how it was parameterized. Software bill of materials for tools and environments, and you're DevOps people, so you know that we're talking about infrastructure as code, or actually everything as code. And once you say as code, it means that we must have a bill of material for it. So all the infrastructure that you have created as code, we need to have a bill of material for it. So we know exactly what it is and how it works. Then we started thinking about the cloud, software bill of materials and the cloud. So if I use a compiler from the cloud, how can I know what is the software, the unique ID for this, so I can use it for my software bill of material? And will I be able to go back to that 13 years from now when I have to do a bug fix for an old installation? Cloud services that we are using, or microservices. How do we create a software bill of material for a microservices system that has a lot of small bill of materials, and then we have a global bill of material, and at a certain point your brain explodes and you say, well, let's not do microservices, or if we do microservices, let's cross our fingers and hope that it works without too much bill of material. Or let's get started on this and try to see what we can do as a first step. So we have come to the end, the key takeaways that we would like you, apart from what we have down there in the angle, the corner, that a software bill of material is like a traditional bill of material plus some process information plus general information that you might find useful. DevOps as consumers.
Yeah, you get a list of ingredients where you can query for unique IDs on different objects and For example, look for vulnerability issues. Yeah, and during our work with our white paper, as Lars said, we came across hundreds of use cases, but we have tried to narrow it down to around 10 use categories and 3 types of things that you need in your software BoM.
So DevOps as producers of these software bill of materials. Well, as some DevOps people, they say, you build it, you maintain it. So you build it, you create the software bill of material. You are sitting at the origin of most of the data that we need to put into this software bill of material. You know exactly what source code goes in when it gets built in our pipeline. You know what tools that we have in the pipeline. You know what options and parameters that we are using, and so on. Maybe you don't know the licenses for the third-party libraries that we're using, or the export control things, but that are sort of minor issues that you can get someone to tell you. But you built this binary, and you should be responsible because you are the best suited person to do that. Automation, DevOps people, they say do it once, do it twice, automate. So as a user, as a consumer of a bill of material, if I want to use it the Wayne Babbitt's way, it doesn't work today, it worked yesterday, let's compare the bill of materials. Unfortunately, in the bill of material department, they say, we will have it ready in a couple of weeks. Then you'll get a document, an Excel spreadsheet or whatever they're using. So I have to sit and twiddle my thumbs for 2 weeks. Not when you are responsible for that. You create it automatically. The second that we have the build, we also have the bill of material. And I can start using it. Reproducibility is a very focal issue. So you want to be able to recreate these things. Again, when you're debugging, when we are reusing things from other people. Static and dynamic data. You were talking a little bit about it before, that we have these as queries, and you don't trust one single static result of a query because the world might change. Putin might invade Ukraine, so now we cannot export encryption to Russia anymore. We could before, but not now. So the world is not static. The modules that you have, the fact that you have encryption is static, but it gets compared with outside data. That might change, and we get these dynamic aspects. For some things that we're using version 10 of the compiler will not change. It'll be fixed and a static attribute. Then now we want to show, are there any configuration management people here in the audience? A couple of people. What does this look a little bit like? Krista, this is an exam. Yeah, we're having an exam today. So we started looking at it, and at a certain point we looked at each other and said, well, doesn't it resembles a little bit like configuration items that can have attributes with how they were created? And then when we are interested in getting information, that is configuration status accounting. Which back in the 80s, configuration status accounting was that you delivered a printed report every 2 weeks to the project manager. Modern configuration status accounting is that we have all the configuration items with the attributes and the relations in a configuration management database. And then we have queries. And if you want to know something about the data in the configuration management database, you can do a query. If we have some standard queries, we can sort of, as configuration managers, we can automate that, and you don't have to write select from where and whatever it is that we need to do to query this database. So basically, these software bill of materials, they contain a lot of information. They are sort of small databases for the configuration items. If internally we are using these software bill of materials, we don't have to create them as documents. We can create them as queries, to live queries on the database, which means that you'll get current information. If things in the world change, when you query this, then you'll get the new information. When we were sort of running through the presentation yesterday, at this point, then Andreas looked at me and said, "Oh, that reminds me of the good old days when we were using ClearCase and we had latest in the specification. You never knew what you would get." Yeah, you knew that you would get the latest, and to a certain degree, when we have something that is dynamic and we do it as queries, then we will get the latest. And that might change. Yeah. So there's also something in it for the configuration managers. Configuration management is useful. And software bill of material is a hardcore, fundamental, central thing for configuration management. Wayne Babbage wrote about it in his book from 1986. ClearCase has had it since the early 80s. It's been maybe not a central thing in the configuration management course that I teach, but it's been a thing that I've told my students about. And now Biden has made it popular. That's great. Any questions? You can, the audience here, if you're not on YouTube, you can take a photo of this. Young people, they like to take photos. My wife likes, it was live streamed this. My wife, she loves to take photos of the food that she eats. You should take a photo of this. We have some information on this page, and we are still working on the white paper. And eventually the white paper will be published, and you can find the information there. And eventually we will also put some of these hundreds of use case, specific examples of use cases that we found available. But generally from the use case categories that we have sketched here, then you should be able to use your imagination and fantasy and say, well, in my company, that kind of use case could be like this. And then you get something specific. Any questions?
Crystal clear.
You said it's been a lot of work about the representation format now during this, and of course the final software BoM, the format of that is of interest. Of course, you can compare, but also one way to achieve this might be to like tag source code or to tag all these different objects that you want to keep track of, and then when you build the system or you compile, you bring these things into the record. Is this notation of how to tag things, is that also included in this representation they work with? So like people doing compilers and build system can use that format and not invent it for every company.
We have not looked very much into the details of these formats. So I think that they have focused on two formats that they've been working a little bit on the past years. One is Cyclone DX and the one is SPDX. And that is basically, since the single use case that they have is list of ingredients and vulnerability scan. That was their focus. That was the assignment that they were given. Then it's a list of unique IDs, and if I need to scan for Log4j, I just figure out what is the unique ID for Log4j, and then I just scan through this list. These formats, some of the things that I've been talking about for these formats is whether we would be able to look into the details of a library and see also the detailed components that are in the library, or if it is just a flat list of
I was more into, I mean, if you have a source code, where do I tag and what is the format of the tag in the source code? If I have a binary, how do I tag that? If I have a system or tool, how do I tag that? So I then can find these tags and I mean, create the build. And if we have a standard for that, then we can all tag in the same way.
Yeah. So well, you're an academic, so you know what is in the end of a research paper. There is something called future work. So the NTIA has done a good job and a lot of work on trying to create this format, but their focus has been this narrow list of ingredients and scan for vulnerability or scan for unique IDs. So that is sort of the current state. Then industry and the users of these software bill of materials, they will have to sort of evolve this. So if we also need to have some process information, how should we get that into a bill of material format? If we need additional information like licenses or export control or whatever, what were the test cases that were run and what were the results of the test cases or the release notes from that I showed from Zoom, then we need to figure out how we will do that. The easy way is that we keep it internally in the family, because then we can just have it in our configuration management database, and then we just create items with attributes and relations. But when we have to talk to other people, I know that Axis is publishing software bill of materials for some of their products. They have started on doing that. They don't do a complete software bill of material because there are some of the items in their products that they are not allowed to reveal that they have in the product. So it's sort of washed. But they are moving towards, at least they have started on this journey. Personally, I doubt that an external software bill of material will be very useful. One of my brothers is a user of software. He would never want to have a software bill of material. But he would very much like the company that sells him the software to have a software bill of material internally. And to promise my brother that once every day we will scan this software bill of material and compare it to the latest list of software vulnerabilities. And if we find a software vulnerability, then we will notify you. Joe Biden has people to do that for him. So he can ask you to deliver the software bill of material because I don't trust you to scan it. I will scan it myself. But I would guess that most of your customers, they wouldn't care. They would prefer that you demonstrate to them that you're capable of creating a software bill of material and that you will regularly scan it for the things that should be scanned for. And that you know who has bought your software and that you can contact them in case that they need to upgrade quickly.
More. but still, if I am a company and I buy software from many different places, of course, these still suppliers should have their own software boom and keep track of the software themselves. But if they just provide me this software boom, then I can have a third part making sure that I don't have software at all in my company that have bugs or not bugs, but the security problems.
Yeah.
So because they will look into the different software booms, even though they didn't make the software. So by exposing this externally, you can still do some research yourself or let someone else do it on your code, I suppose, and not rely on each supplier.
I'm a software configuration manager, or I'm not a configuration manager. I'm teaching software configuration management, and I've been talking about software bill of materials. When I buy a product from Axis, I really don't care about the software bill of material. But if your company buys something from Axis that you integrate in your product, you'd probably interested in Axis being able to supply these software bill of materials. So in business to business, it will definitely be a very good and very useful thing.
We actually have one question online as well. It's sort of been answered, but I think the speakers also get a chance to answer it. And it's, what kind of tool can one use as a database for CIs? Is this similar to a, I don't know what this is, PDM tool? Example, SolidWorks. I guess the first question is, what an example of a tool as a database for CIs?
One of the things that I'm trying to teach my students on my course is that most of the questions in software configuration management has an answer that starts with "it depends on." So we were talking before about how much information, how much of the build process, and how do you need to conserve a 15-year-old compiler? Well, if you're ABB and doing control software for nuclear power plants, if you're Alstom or Bombardier doing software for the trains, yes. If you're Spotify, you don't look back, you don't care. So it basically depends on. In many companies, a configuration management database is synonymous with a Git repository. All the things that are important for us, we just shove them into our Git repository, or ClearCase in the good old days, or whatever. It's not perfect. It's not a database. It was never intended to be a database. You cannot have attributes for your configuration items. You cannot relate one configuration item to another, but you conserve them and you make sure that uncontrolled changes will not happen. And if they do happen, you are able to turn back. And you have sort of your basic database there. Then you can sort of have that at one level, and from time to time, when you release software for a car, then you don't want to go into your Git database, and you need to have more information, more attributes about this. And then you will say, well, during the development, our developers, they are more than happy with the little information that they can get from a Git database. But as a company, we really need to have a lot more information attached to our configuration items. And then you would move to a database or a PDM, product data management tool. What tool you would prefer to use, then usually that is not a question. Sometimes my students, they have the illusion that when they go out and work in a company, they can decide what tool to use. They become wiser. We are using this tool for the configuration management database. And they say, oh, so you're still using CVS in this company. So it depends a lot. Yeah, more questions?
I assume I already have the answer to that one, but have you looked into how to maintain all of these? We are talking about keeping in certain instances when it's a company that has a long-term engagement, that you need to keep them for 15 years, 20 years, or whatever. How do you keep the tool chain for that one? Because if you're using a tool for that one, it might be hard in 20 years to actually get that tool or that version that you used. You have it documented, but you can't get it at a later point, perhaps. Have you looked into that part at all, or that is to be continued?
Yeah, not in this work, but yeah, in my career, I've heard, for example, medical companies actually take the computer that they used to build the software and put it in the safe, so they can boot up the old operating system with the old tools and everything. So it depends.
Thank you.
But basically it means that if we want to be able to go back and use old software bill of materials, then everything that is mentioned in the software bill of material must be preserved. And I know that your boss will say, no, we don't need that. We don't have money for that. If you have a contractual obligation to be able to do that, then that's what you have to do.
A question. We are talking about the complete chain here, where we do like the bill of material, but in the last instance that you had now, you could actually come away with that if you have the stored binaries at that point along with all the other artifacts around it, and not have the source code, don't have the build environment, you only have that except configuration item. Then you have the problem of actually showing that this is the same that you actually delivered, but that you can have other ways of making true. That means that you might not need all of these things around it, so to say, all the tools used and so on. You need to document it, you need to know about it to have vulnerabilities that might be found at a later point, but it might be enough to only have the actual artifact created during the production, so to say. Or?
I've had that discussion with Christian Pendleton. So he says, I don't care about reproducibility because I don't want to rebuild stuff. I mean, hard disk is so cheap these days that we just keep the binaries. So we don't rebuild them, we just have them. I see two problems in that. One is that it's not a question of disk space, it's more a question of mental space. If you have hundreds or thousands of different items floating around, then you need to structure it very well, otherwise it becomes chaotic. The other thing is that if I keep these binaries because the customer say, oh, I lost the binary, could you please send me the binary again? Then, yeah, it's faster and easier if I have the binary and he can download it. But if I have a 20 or 30 year maintenance contract on something, and I need to go back and add a new functionality or fix a problem in the code from 15 years ago, then I know someone has told me that there are ways of going into a binary and change the binary. But I would prefer to go into the source code from 15 years ago and then to recompile it and run all the test cases again and everything to make sure that I didn't disturb anything by my bug fix or whatever it is. So depending a little bit on what's the reason for sort of reproducibility. And sometimes keeping the binaries and the information about the binary is sufficient. So then we don't need to keep the whole tool chain.
Thank you.
We ready?
Yes.
Yes.
Are people hungry?
Give them a big hand.
Thank you, Lars and Andreas.